Hello, civil engineers. Welcome back to the lecture. So now we'll try to see some other things what is given here. So the next thing is typical column size reduction detail. So what do you understand by this? So usually what happens whenever we give the column, usually from the foundation level up to the top floor, the size of the column will be usually same. In some cases, what may happen, let us say if it is a 4-story building, G plus 4, up to 3 floor, you are given the column size of let us say 230 by 450. But in the terrace portion, you might have felt that much size is actually not required. So instead of giving 230 by 450, what you have done is you have gone with a 230 by 300. So almost a 150 reduction in the size has been done. Simple. So that is what he's trying to tell us. Typical column size reduction. When you have such things, then how do you take care of the reinforcement? So he's telling us now that you bring a bar from here. This is, let us say, it's your third floor. So you're bringing a bar from the third floor, bring it like this. Then what you do, you need to give a small kind of crank, or you can call it as a kind of a joggle. Just bend your bar like this. Okay. What you are supposed to do, just you have to bend the bar and then you take it straight. This is your next floor. This is your terrace portion. From the terrace portion, this is your terrace portion. Okay. So in this particular portion, what you do, you try to give this small bend. Now this bend should not be too much. So it's telling to maintain a slope of 1:6. Got it? You're supposed to maintain a slope of 1:6. That is for every 100 mm rise, you can give a 6 mm slope. For every 100 mm rise, you can give a 6 mm slope there. Got it? So a small gentle slope, like for when you do the lapping, this is how you bring a bar. A small crank you'll get, not crank, a small bend you'll give, and then you'll take a bar like this, isn't it? For the case of lapping, the same thing you're supposed to do here. Only the thing is this particular portion you can little extend. Something like this you should take and go it. Got it? So this is what is trying to tell us. So this is a 50 mm max above bottom of the slab or beam. Okay. Remove the latines from the top of the column. Concrete column ties as scheduled. For sections having more than 4% steel, only 50% column reinforcement to be spliced at one floor. This is what is trying to give us. Okay, fine. So you understood the concept. Sometimes what people do, what people do, they don't follow this. They'll bring a bar and then they'll give too much slope like this. Like this, they'll give a slope. Like this, they'll give a slope. And then they will take it inside like this. So it's telling you shouldn't do like that. This slope you need to maintain 1:6 slope. You need to maintain there. Got it? Got an idea? So when you have a column of two different sizes and you're bringing a bar, this is how you are supposed to take care of it. Rest all things, what is trying to tell, this particular portion, what is trying to tell, 50 mm max above bottom of slab or beam. That means this will be your slab or the beam bottom. No, from there up to only 50 mm, this portion should come. Okay, it's like it's telling us this much portion what you're bending, no, this much. So this should be 50 mm maximum above the bottom of the slab or the beam. So you cannot go like this too much. Up to here, you cannot go and then take it like this. That is telling us only. That means you bring a bar, you give a small bend like this. So this bend should be only 50 mm, either from the beam top or either from the beam or the slab top. Depends where you're taking the bend. Okay, and then this 75 or less. So this is actually this thing, clear cover. Why it is clear cover? See, now this was your column. Initially, this was my column. This was my column, right? Now, since there is a reduction in the width of that, so this has become your column now. This is your column, isn't it? So usually in the column, we try to give a cover of 40 mm. Here is trying to tell us this should be 75 mm or less. Okay. So from here to here, it has to be 75 mm or less, not more than that. Next, for sections having 4%, it's not required. This is from a design point of view. But anyhow, this particular point still stands valid. That is, we should not do the lapping for more than 50% at one particular section. If there are 8 bar, only 4 bars you have to lap at one section. Remaining 4 bar, you take it to the other section. Simple. So this was all about the typical column size reduction. Next, typical detail of column for different sizes. Yeah. Okay. Typical detail of column for different sizes. Okay. What do you mean by different sizes? So this is nothing actually. If you try to understand typical detail of column for different size, actually what has happened here? Again, same thing. Again, same thing. This is one column what we have. This is one column what we have. Then after that, your column has reduced. This is another column what you have. So here again, there are two different sizes, isn't it? So that is why he's writing typical detail of column for different size. So in that case, you can do one more thing. What you can do is, what you will do? Yeah, you'll bring a bar from here. Then this bar, if you don't want to continue here, okay, if you don't want to continue, you can rest this bar, bring the bar, give a development length to that and stop it. You can insert this particular rebar inside the beam or inside the slab. Usually it will be inserted in the beam only, because anyhow that is a junction. Similarly, you brought this bar, okay, then you end it here. It should be ended like this. Got it? It should be ended like this. After that, next bar you need to start. Okay, I'll tell you how exactly it will look. Next bar you need to start like this. Like this, you will insert the bar. Okay, like this, you will insert the bar. So this length from the top of your slab, this length, whatever you have, no, this should be LD plus 10 times the D, this length. That means if you're using a 12 diameter bar, and if your development length, let us say 50 times the diameter of the bar, I'll take an example. Let us say this red color, you're using a 12 diameter bar. So it will be 50 into 12, keeping the development length plus 10 times the D, plus 10 into 12. So it will be 600 plus 120. So it will be 720 mm. So this will be 720 mm. So this has to be how much? This one, from here to here, from the top of your slab till this, it has to be 720 mm. Same here also, it has to be 720 mm. Understood? So this is your development length. So that much amount of what you call rebar is embedded. Now, how you will embed this? That is a big question. So usually what happens, what we do? Usually what happens is we'll try to drill a hole. For example, what I'll do is I have a bottle. Yeah. For example, if this is my column which is ending, okay, which is ending. Now what I'll do, I'll drill around, say this much amount it has to go, no? How much? 720 mm it has to go. So of course, what you will do, you'll insert 720 mm inside this particular thing, and from here you will take your bar. You getting my point? So here, of course, drilling is not required here, because anyhow we will insert a new bar. So what you're supposed to do, this bar you need to insert when you're doing the casting of this column. For example, if this is my column where I'm casting this column, this particular rebar I know in the next floor, I know that I need to insert this rebar. So what I'll do, this much length, how much was this? 720, I'll insert inside this 720, 720. Let us say if there are 4 bar, this will go up to 720, 720, 720, 720. And once the concreting is done, it will get enough, what you call, stiffness. And then you can do the lapping of that if you require. But lapping always at the center only, you're supposed to do that. Got it? Yeah. So that was all about this point. Now the next question comes, why this has to be done? So usually what happens, like I told you last time, see, I told you once that, what did I tell? Yeah. If this is a column, hmm, if this is, I'll show in plan. Okay, this is one column. This is my column number 2. Okay. Okay, I'll do it like this. Fine. So let us say, understand this in this way. This is my, let us say, second floor. This is my second floor. I'm showing you the plan. Okay. This is my second floor. And this is my third floor. Okay. Third floor. Now let us say in second floor, I'm using some reinforcement. I'll go with this reinforcement. Okay. Yeah. I'm providing one bar here. This is my second bar. Then I'll provide one more bar here. Then I'll provide one more bar here. 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 Got it? Good. Now in the third floor, I don't require this much reinforcement. Two things I'll explain. If you see the size of the column compared to this size is little shorter. I'll write that also. Let me say this is 230. And this is, let us say, 600. Okay. So in the third floor, what happened? This anyhow, I'll keep 230 only. And instead of 600, I'll make this as 450. Okay, now there is a reduction in the size. So if there is a reduction in the size, now two things will happen. First is that now try to understand. I'll club both of the clauses what we saw now. Okay. First thing is that see this particular rebar, this particular rebar, this bar, and this bar is not required. Why? Because this 1, 2, 3, 4, these four bars are not required because my column size is only 450. This is somewhere here, so I don't require this bar. So if you don't require this bar, then what you can do, you cannot directly cut off. You cannot directly, if this is your top of your column, if this is the top of your slab, you directly cannot stop your rebar here. So in that case, when you bring the rebar, no, what you're supposed to do, you have to bring it like this. You have to bring it like this and then take it inside your slab. Like this, you have to cut off. Getting my point? So I'll bring a bar like this, and in the inside, I'll be cutting it off. That is the first way. So 1, 2, 3, 4 bar you have to bring like this, and then you take it inside the beam and the slab junction. Inside you can insert it. How much it has to be inserted? It is given from this beam. This is a beam. From this beam, this much length should be LD. That is development length plus 10 times the D. Got it? How much from here to here, whatever bend you're taking. So you have to calculate. If you're using a 12 diameter bar, we found it to be how much? 720. So this length from here it is, from the bottom of your beam. From the bottom of your beam up to this much, it has to be 720 mm. So it's called as the development length. So that much amount of stresses are generated there. Simple. That is for this bar, this bar, this bar, and this bar. Now coming to the other three bar, 1, 2, 3, 4, 5, 6. This 6 bar you can directly take it. 1, 2, this bar you can directly take it to the top. But the problem may come, to this particular rebar. Okay. In that case, you can give a crank. This bar, whatever you have, no, slightly it is outside. Slightly, if you take it straight, no, you'll not get the enough cover. So in that case, that another clause what we had, no, that is you'll take a bar like this, bring the bar, and from here you give a small crank, and then you take it like this. Understood the concept? This bar, anyhow, here it is no problem. Here I'm showing. So if you don't get a proper cover, then you should do like that. That is what was mentioned here. What they mentioned, see, typical column size reduction details. So in that case, what you bring a bar, give a small crank and take it. Understood both the concept? So this 1, 2, 3, 4 bar is gone, and this bar will go straight. Now, other than that, one more thing will happen. One more thing, for example, let us say this particular rebar, this bar and this bar, you're using a 16 diameter bar. We are using a 16 diameter bar in the second floor. But when you come to the third floor, this two bar, I'll draw it here. This bar and this bar, you don't require it to be 16 diameter. I want that to be a 12 diameter. So in that case, what you will do? You have two options. You have two options. Again, if you don't require this two bar to be taken here, then what you can do? You can do the lapping. This 12 diameter bar, it will look something like this. This will be a 16 diameter bar. Your 12 diameter bar will come from the top, and you'll give a crank and you'll do the lapping. So this will be a lap length. This will be a lap length. This is one way you can do. Okay. The second thing is that another thing is that, see, you cannot only leave your bar like this bottom bar. It has to be taken like this. So this much development length you are supposed to give. That is LD plus 16 times the diameter of the bar. You can see the same thing here. See, this was your bottom bar. No, you brought it like this and you stopped it like this. So this will be your development length. And then this will be your lap length. And how much should be the lap length? They are mentioned. LD plus 10 times the diameter. So this should be LD plus 10 times the diameter. This much lap length you are supposed to provide here. Got it? Understood the concept? So this was all about this particular two clauses, and I've explained that through a example to you. Yeah. Now come to the another case. So the other case is that sometimes what happens, let us say you already, I'll put it in this way. I have an image for that. So this is one of the floor what we completed. Okay. So you can see 1, 2, 3. These 4 columns are there. Now this is a terrace portion, and you don't have to do any construction here. Maybe after 1 year or 2 year you found that no, you need to put another small slab here. So in that case you want a rebar, isn't it? In that case you want a rebar. That means you want to put a reinforcement bar, and only then you can raise this particular column. Now how you will take care of this additional rebar? For that, what we'll do is we'll open up this top concrete. We'll just strip the top concrete. And what we'll do, this rebar, no, we'll try to insert inside the concrete. Now we'll ask me, sir, how you can insert? We'll do the drilling. And what we'll do, we'll insert this much rebar inside this concrete, and we'll get this what is that bond, nitro bond will get. Okay, it's a quick fixing chemical what we get. With that we are going to lock it, and then you can raise the rebar. So that also can be done. So usually when you have an old building and you want to put up another floor, in that case what we do, we make use of such arrangement. So this particular clause what they have mentioned is similar to that. Here is telling us that you can see this one, we can see this one, this additional. So this is additional rebar what you have inserted. Okay. So this actually LD plus 10D. So usually when the concrete is already casted, you cannot give this much. How much it is, you know? If I take even a 12 diameter bar, it comes out to be 720 mm. So 720 mm chipping cannot be done. This is for the new, this thing already, I mean, when you're doing a fresh concrete, for that it is valid. But when your concrete is already set, and after 1 year when you're drilling, in that case, you cannot drill 720 mm. So 100 mm, 150 mm is sufficient, and then you have to insert that chemical gel, I mean chemical. Through that, it will have a good bond, nitro bond you can use. This particular thing is when you want to give the new reinforcement, but it's in a ongoing process. Okay, that means this was your third floor, you finished the third floor, and in the third floor, you felt you need to add another 2 rebar. So in that case, you can start with the additional reinforcement. Okay, got it? So if you want, I'll explain it in this way, because in the previous case, I couldn't uh, explain that. How shall I explain that? Yeah. Let us say if this is my existing column in the second floor, if I come to the third floor, it will be something this much. Okay. Hmm. I'll do it like this. Yeah, I can do it like this. Okay. Let me do like this. This may work out. Hmm. And then let us say I provided a reinforcement like this. I provided a reinforcement here. Here also I had provided reinforcement. Here also I had provided a reinforcement. Here also I provided a reinforcement. And then here also I had provided a reinforcement. Here also I had provided a reinforcement. Here also there was a reinforcement, let us say. Here also there was a reinforcement. Fine. Now in this floor, I require reinforcement here. I require reinforcement here. I require reinforcement here. I require reinforcement here. So this 4 bar, I'll take it to the terrace floor. But now again there is a requirement for me to add another 2 bar here. I required here also. I required here also. Now what you'll do, because you don't have any rebar here. That's the first thing. Second thing, this rebar is already taken here. So there is no point in cranking and taking it here. And this much crank also you cannot give, because this slope is more than 1:6. In that case, what we do, this 2 rebar will anchor it. We'll bring up, let us say, this red color is your 16 diameter. This yellow color is a 12 diameter. So now what I'll do, this is my second floor, and this is my third floor. I'll say terrace floor. Okay, I'll write terrace floor. Now what I'll do, in this particular column, okay, in this particular column, what I'll do, I'll bring additional bar. I'll bring additional bar of 12 diameter, and now this much length, LD plus 10D, I'll insert it here. I'll insert it here in this column. I'll insert it LD plus 10, it will go inside, and from here I'll take a 12 diameter bar. Understood the concept? We're able to understand. So that this clause will tell us how it has to be done. You can see this bar they took, and it will be stopped here. It will be stopped here. That means all this bar will be stopped. This bar, this bar, this bar will be stopped. And if you want to put additional steel, you bring the additional steel and insert it into your column, but it has to go up to LD plus 10D. To put it in a better way, I think if I have an image, let me show that. I can show it here also. Let me show it here only. Okay, I can delete everything. Okay, it has 12 diameter. No? So what I'll do, for example, what I'll do, see, this is my beam. This is my slab. Once my slab is casted, the level will be here. So what I'll do is I'll bring the new bar. I'll bring the new bar. I'll bring the new bar and insert into this. Insert and take it like this. Take it like this. So this much length will be LD plus 10 times the diameter of the bar, which is 720. This much 720 will go inside here. Okay. And then you take your 12 diameter bar from here. Got it? Now, another thing, for example, this bar, I want to cut off. I want to cut off in the sense this bar will not go to the next floor. In that case, you will have to bring your bar and you have to take it like this. You have to bring a bar. You have brought a bar. No, this should be cut like this. Cut like this. Okay. I mean, actually, I'm showing you at the top. Usually that will be cut here. You bring a bar. Wait, I'll take it out. Yeah. You bring a bar, and this is your beam and the slab junction. Inside only you take it like. You bring a bar. Inside only you take it like this. And this overall should be how much? Exactly development length, that is LD plus 10 times the diameter of the bar, isn't it? LD plus 10 times the diameter of the bar. Understood? So why this thing has to be given? Because this will create the necessary stresses that is required. This much amount of bar will be embedded. So that much amount of stresses that is supposed to be generated, that will be generated like this. But usually, if you see the general practice in the local construction, people don't follow all these things. That is why in the big construction company, all these general notes are given, and you have to do according to that. You cannot, simply come. You cannot simply stop your bar like this. The quality engineer or the site engineer will never allow you to pour the concrete when you do such things. So you have to bring a bar, then stop it, take it inside your beam or the slab junction, and this much length also you should satisfy on the site. 720 should be satisfied on the site. Understood the concept? So this was all about the general drawing, what was mentioned here. So most of the things I've covered it here, and you understood now how it has to be done. Yeah. Now, yeah. Now, another thing. ADD stand for additional reinforcement. For rectangular opening in the slab, you need to do like this. And for a circular opening in the slab, you need to do like this. For example, let us say I have a slab, and in the slab I give an opening. So I have a slab, and in the slab I have given an opening. Okay. So in that case, what you're supposed to do, I'll draw it like this. This is a slab, okay? And in slab, what I did, I made a cut. I made a, how shall I do that? Okay, I'll do it like this. So this is a slab, and in slab, what I did, this much portion I have done a cut. Okay, maybe I wanted to do a cutout. Maybe I wanted to pass some shaft or something like that. In the slab, I planned it. In that case, what the detailing says that you need to provide additional reinforcement. How you are supposed to provide additional reinforcement? See here, you need to provide ADD stand for additional reinforcing bar of 12 diameter 2 bar. This is 12 diameter 2 bar up to 700 by 700, up to 700 by 700. Okay, and then he's telling, then you have to give this cross bar like this, which is a 12 diameter 1 bar at the top and the bottom, here, 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 and here, and this length should be 1 meter. Got it? You're able to understand. Now how you do that? That means practically on the side, what we'll do, no, we'll bring an additional rebar of a 12 diameter 1 bar, and in the slab only, since it's a cutout here, I'll provide one rebar like this. Not right. First I'll do this one. Additional reinforcing bar, 12 diameter 2 bar. So what I'll do, here I'll provide 12 diameter 2 bar, 1 bar, okay, and 2 bar like this. 2 bar, I'll keep it. Here also I'll do the same thing, 12 diameter 2 bar, and here also I'll do that 12 diameter 2 bar. Okay, you're seeing it from the top, okay, in the plan. We'll provide it, and then what we'll do, we'll give this crossbar. This crossbar is one here, then another crossbar I'll give it here, another crossbar I'll give it here, another crossbar I'll give it here. So this length, whatever you supposed to give, no, this one, from here to here, it will be 1 meter, 1 meter, 1 meter, 1 meter. All these are the 12 diameter bar. So why this has to be done? That is a big question. So the big question is that since you are removing a large chunk of concrete, when it's opening, you don't have concrete there. So as a result of that, there may be a chance because of the stress concentration, cracks may appear. So these cracks may come even in the inclined direction. So that is why they have given this inclined bar in this direction. Okay. So because of since the stress concentration won't happen uniformly due to the not proper distribution of the stress concentration, what will happen? There is a chance you may get a cracks in all this direction. In order to avoid the cracks, what we do is we give this additional reinforcement so that it will take care of that. Okay, that's the reason for that. So this is for the rectangular. The same thing if you're doing a circular opening. This is rectangular opening, no? If you do a circular opening, in that case you follow this. If it is a circular opening, then you have to give something like this. Okay, fine. Understood the concept? Up to 700. Okay, okay. There are additional reinforcing 12 diameter 2 bar and 16 diameter 2 bar. This much is given. Up to 900 by 900, I feel this 900 by 900 is, I think, this much, up to this much area you're supposed to give. Okay, it is mentioned here, no? See, it's telling up to 700 by 700. That means this length will be 700. This also will be 700. And 16 diameter 2 bar. That means up to 900. So this length will be 900 and this will be 900. So throughout you're supposed to give a 12 diameter 2 bar and 16 diameter 2 bar combination surrounding to all these things, so that you are giving additional reinforcement so that the cracks will not appear. Got it? So this is what mentioned here for additional reinforcement whenever there is an opening. After that, this is a construction joint. So next is about the construction joint. See, construction joint in the sense is nothing. Actually, what happens is that, for example, if I have an image, I'll explain it there. Here I cannot explain it. This also cannot be done. Anyhow, not required. I'll explain it here only. Hmm. So what about the construction joint? Usually what happens when we do the casting of a column, suppose if I am doing a casting of a column. So let us say if there is 3 floor. So if there is 3 floor, suppose if it's a 3 floor, okay, I'll say this is floor number 1. Okay, then it is floor number 2, then it is floor number 3. Okay, so when you have 3 floor of a building, I'm taking it for example. So you'll not do the casting of the column in a single go. So you'll be casting the column this on one single day. After that, you'll be casting this on the another day. This you'll be casting on another day. So it's telling us typical construction joint. So typical construction joint, floor level. Okay, fine. Floor level and this one. 45 you have to take it to top. Huh. So what is telling? So once you cast this column, then you'll put the beam and the slab. After that, next again you start with this particular. Okay, wait. I'll show this through an example only. Give me a minute. Yeah, you see here, this is a column what you are casted. I mean, that means column was casted, your slab has been put up. This is the next floor. So next what will happen, when you pour the concrete in this column, what will happen? This is already an old surface. This is already an old surface, and the concrete which will come into this column will be a new surface. So as a result of that, the proper bonding will not happen. So why? Because the proper bonding will not happen because it's an old surface, this is a new surface. Because of that, the proper bonding will not happen. So keeping that in mind, what they have done is they have given that you're supposed to provide a construction joint. That means if this is a column, that means if this is your column, okay, if this is your column, what you can do, this much portion, you bring it like this, you cast it like this, and you can give a small depression here. A small depression you give like this. So that tomorrow when you pour the concrete, that is new column, because of this kind of, rough joint what you are given, the proper bonding will happen. The proper bonding of your column will happen. I mean, with this column and the next column what you're casting, no, the proper bonding will happen. So these people have given something called as construction joint. But usually in the site, what happens is people don't follow that. Usually what happens is we don't follow that. Okay. We don't, whenever we do the casting of the column, if you see it here, no, where is that? Yeah. If you see it here, see, we casted this slab. We did not do anything like this. According to that drawing, it should have been in near this portion. What you do, you have to give a small depression. I mean, make a small hole like this in this way. So that in this way, you make a small hole from both the sides. This will be a kind of a depression. So that when you cast this particular column, because of the depression and because of the rough surface, what will happen? You'll get the proper bonding. But that is what they're trying to tell us. But usually people don't do all that. They do a simple casting, and after that what they do, when we pour this thing starter concrete, no, in the starter concrete we'll do the same thing. For example, see here, you can see this is the normal we have done. This is a starter frame we'll put up. In the starter frame you can see these people will make it something rough. So this is a starter frame. Here people will make it rough. Some people will just keep the stone aggregates inside this so that it will create a kind of a depression and good bonding will happen. Some people, what they do is they don't do that. Some people don't do that. Some people will try to make a hole here. Inside this much portion, you make a hole. You leave a gap. I mean, you don't fill your concrete into this. So as a result of that, what will happen? A kind of a depression will be created. So this is called as a construction joint. Got it? So if you do that, it's well and good. But overall, it doesn't make any difference. Okay, as long as you're using your vibrator properly, and if you're properly placing your concrete, if your quality of the concrete is good, it doesn't make any sense. You can see here, I think somewhere here, they've given a depression, maybe here. Here, if you can see, kind of, He has given a kind of depression. I mean, he has made the particular area rough. That can be done. That is what the code says. That is what they are told in the general drawings. Yeah. See again, all the mistakes you can see it here. The proper lapping and all. No, they have done the lapping here. See again, this is a local construction. So people don't know all these things. They keep on doing the construction, which is not a right construction practice. You shouldn't follow all these things. They have done the lapping here. According to our logic, the lapping is here. He has done properly. One that even though he has done at the center, it's not exactly at the center. The lapping should come in this region, in the middle region. You can see. You can see here how he has done the lapping. He has done the lapping in this only, which is again wrong. So this is a problem what people create. Of course, when you work for a big construction company, when they follow quality, they don't do all these things. Of course, they'll never allow you to even tie the reinforcement when you do such things. They'll make you remove all the reinforcement. Then exactly at the center, you try to do the lapping, and only then they'll allow you for the concreting. You see here also the lapping has been done at this particular junction, which is not allowed. But again, it's a local area, no? So people don't follow that. Yeah, I think you understood the concept, no? But again, it's not required. If you want, you can do that. So this is typical construction joint in the column. So you can give a kind of a depression like this. How much depression? 40 mm depression, 40 mm hole you can make. Either you can make like this or you can make it like this. Doesn't matter. Fine. Yeah, section 1 and section 2. Section 1 is like this. This way, if you cut, it will look like this. Overall, a kind of a depression will be created inside the column. Okay, that's it. Next is typical construction joint in beam it is. So this is for the beam. Okay, again, this is for the beam. So in the beam, usually what happens is, again, see, why this construction joint concept comes in the beam. Usually, we don't provide any construction joint in the beam. Usually, when we start with the concreting, beam and the slab concreting will be done together. So we plan in such a way that in one single day, entire slab casting and your beam casting will happen. But sometime, due to, let us say, you started a concreting and suddenly it started to rain. And it rained so heavily that you have to stop your concreting. Now, unnecessary, we cannot stop the concreting wherever I like. Okay, this construction joint is not a major problem in the column, because in column, we cast like 3 or 4 columns in a single day. Hardly you get 2.5 meter column height, and it's not an issue. But the problem of this construction joint comes in case of a beam. Now, in the beam, what happens? For example, you started concreting. For example, let us say, I'll do it like this. Yeah, let us say this was my first beam. Okay, I started concreting this. I started concreting this particular beam. I mean, these are different beams what I'm showing. Okay, fine. And then, fine. Okay. I'll do one thing now. Finish. Okay. Now let us say this is a beam I'm showing. Okay, beam number 1, 2, 3, and 4. You started the casting. You casted this beam. You casted this beam. You casted this beam, and almost you were casting this beam. It started to rain so heavily that you left the concreting. Now, when you leave the concreting, what happened? You came back after 2 hours. So as a result of that, a kind of a joint is created. So that is called as a construction joint. Got it as the first thing. Now what happened? You cannot start your concreting directly from here. So that is why whenever you're leaving a construction joint in the beam, you need to understand the concept of the bending moment. Wherever your bending moment is minimum, or at the point of contraflexion, you have to stop your concreting. For example, I know if I take a simple beam, I know that if I take a simple beam, where shall I take? Yeah. How it will happen? This will be a negative bending moment. It will be positive and negative. Or let me do one thing. I'll draw it here only. If I, for the same beam, you'll be having a negative bending moment. Then you'll be having a positive bending moment, and you'll be having a negative bending moment. Right? Now you tell me at which particular point you should stop your concreting. This particular point you should have stopped, because it's a point of contraflexion. Or if you had started from this side, or you could have even stopped at this particular point. I'll make it in a different color. This was a point where I should have stopped my concreting, or I could have stopped my concreting here. Why? Because these are the point where the point of contraflexion happens, where your bending moment is minimum. So if I stop my concreting here, nothing will happen. But now I stop somewhere in the middle, where actually your sagging bending moment is maximum. So since your sagging bending moment is maximum, the moments are higher, and you have stopped your concrete. And when you start your next concreting, this particular point will become your weak point. The moment it is weak point, of course, this particular point only is subjected to higher moment. There is a chance, there may be a chance of small cracks and kind of a small failure. Failure in the sense doesn't mean that complete beam will fall. That usually doesn't happen. Small cracks may come. So in order to take care of that, the code says is, or this general drawing says is that you have to plan in such a way wherever is a point of your contraflexion, there you have to stop your concreting. Or let us say rain did not come. Let us say rain did not come. Today you started with concreting, and by the time it was 6 o'clock in the evening, all the laborers got tired, and also the electricity went off. So you tried everything, but you couldn't bring the electricity, and you couldn't start with your concreting. And you told tomorrow I'll start the concreting. So when you know that tomorrow you're going to start your concreting, then what you do? At least today you finish your you finish your beam concreting up to which point exactly. Either you could have stopped it here, but you didn't know that. No problem. At least this much portion you do. This much portion at any cost you do. So that what will happen? You're stopping at the point of contraflexion. So tomorrow when you come, you start your concreting from here. Not an issue, because here your bending moment is very less. No, not an issue. Nothing will happen. That is a first concept. Second is that whenever you are stopping, also there is a concept to be followed. Whenever you are stopping, you cannot just stop like this vertically. If this is my beam, I cannot stop in vertically, because tomorrow when I pour the next pour of concrete, no, it will not stick here. So then he says us what you are supposed to do. You have to bring it like this. Okay. Then here you create a kind of a depression and bring it like this. So how shall I do it? If I show it in this way, how shall I show it? Yeah, I think I'll show it practically only on some this thing beam image. If I have a beam image, let me try with that. Okay, I think I require one beam. I have a beam here. I'll do it here. If I get one external beam, no, I could have shown it to you. Let me think where I can show that to you. Exactly. Now here I can show. See, let us say you consider this to be a beam. So you cannot, stop your beam like this. So what is trying to tell us? You stop it something like this. You bring it, and this much portion, you create a kind of a depression like this. Like this, you are supposed to create. So this portion, no, you take it inside, and then you take it outside, something like this. Able to understand, no? This will not be straight. It will be like this. Then it will be something like this. Yeah, this would be great. You have to stop like this. Got it? So if you stop it like this, what will happen? Next day when you start the concreting, since you have created a kind of a depression, your concrete will go inside this, and because of this, a grip will be created, and not an issue. And anyhow, you have stopped at the point of contraflexion, so where there your bending moment is very minimum, so no failure or no cracks will happen. So that was the entire concept of the beam. Understood? Understood how it has to be done? Huh? So practical, you are supposed to follow all these things, but again, very few people follow this. Okay, very few people follow it. Even if you cannot give this depression, at least stop the this thing concreting at the point of contraflexion. Okay, that you have to keep in mind. Understood? Chalo. I think this also understood. Now they have given, like now exactly you'll ask me, sir, you told at center. How exactly I can select the center? Then he's telling us what you do is whatever is the depth of the beam, from the top you leave, I mean from the side you leave d/4, from this side you leave d/4, and this middle portion you create a kind of a depression like this. Understood? So if your beam width is, let us say, 300 mm. Okay, what is d/4? What is d/4? 125. 125 is one, not 125, 75, right? D/4. Yeah, 75. Wait, 300/4, no? Yeah, 75. So let us say if you have a beam, yeah, and the width of your beam, okay, the width of your beam is, let us say, 300. What is 70? What is 300/4? 75. So now what you do? From here you leave 75, and you create a depression of 40 mm like this, and now this will be 75. So this will be 75, and this will be 75. 70, 75, 75. How much is done? 150 is done. The middle portion will be again 150. This will be 150, and this step, that means inside your beam, like this you are going to cut like this. Okay, so that will be 40 mm. 40, and see exactly, you don't have to do the 40 mm and all. You can even give 50 mm, but try to make it something like this. That's it. Shapes should come like this. So tomorrow when your new concrete comes, when a new concrete comes, your concrete will go and stick to this part. So what will happen? A good bonding will happen, and then of course this concreting will happen. Got it? So it's something like you're connecting two pieces. Okay, it's something like how you used to play that puzzle, right? The puzzle was something like this. Let me do that. Yeah, how you used to play the puzzle? Yeah, puzzle was something like this. No, it's square. It will be like this. No, how it will be? Yeah, it will be something exact. Now you got an idea. So this is a puzzle, right? Then what you do? The next same shape you'll bring. It will be connected like this. Bring it like this. Hmm. Like this. You'll bring it like this. Bring it like this. Bring it, and this portion would have been from this particular portion will be inserted like this, and this would have been like this. Understood that puzzle? Same thing, same concept. Yes. Now you understood. Now this depth, how much it has to be? That is 40 given. Simple concept. Okay. Yeah. See, few people tell something called a shear key and all. That is a wrong concept. There is nothing called shear key. Few people, I've seen many people in YouTube and all. They show something like this. Okay, they show like this, and they say this is shear key. There is no concept of shear key. Shear key is usually is usually for the your this thing, bridges and all, where the sliding will happen. So many people teach you wrongly, telling that it is a shear key. There is no concept of shear key and all. Yeah. After that, now this is typical T junction detail. Same thing. Okay, typical T junction. Typical T junction in the sense, for example, I told you, if this is my last floor, this my column came, and this is my last floor. Whatever reinforcement of your column you are bringing, you should take it inside like this. Okay, you should take it inside, and then finally you will do the concreting, and this is the last slab or the last floor. Okay, understood? It's telling us that, and there also same concept. Typical T junction detail, bring it, take it inside, take it inside. So practically, if you want to see something like this, see, for this is last floor. I don't have any other floor. Now I brought the column reinforcement. I'll bring my, I mean, how shall I do that? Here also I can do that. I'll bring my column reinforcement, and now small insert I can do like this. Okay, you bring your column in reinforcement and bend it like this. Of course, it's a small size, no? So I'm doing it like this. So you have to bend it like this. Got it, no? So in that way, suppose if you're not raising this column and you were stopping it here only, in that case, you can take a LD plus 10 density and put it inside the slab only. Since you have taken it to the upper, you can bend it. Anyhow, the main intention is this rebar shouldn't be exposed. If it is exposed, then due to contact with water and all, rusting will happen, which is not a good practice. So it is telling us. Okay. Yeah. Same thing. This is for the corner L junction detail. This is for the L junction detail. In the side also, you're supposed to do this. Okay. Chalo. I think, yeah, entire drawing I've explained you. Entire drawing is explained. Only the thing is, what all is left out. This is understood. No? 1:6 slope, the same thing, same thing. And this is for the lintel. So the lintel, this is for the lintel. I told you in one of the drawing I explained you about the lintel. What used to happen there? The size of the reinforcement details of the lintel was depending on the openings, right? Whatever is the width of the opening, based on that will decide. So same thing they have given it here. If you have a window up to 1.8 meter, you provide the breadth of your lintel 200, depth is 200. If it is from 1.8 to 3, provide 200 by 230. If your width of the opening, like window and all, or let us say door opening, if it is from 3 meter to 4 meter, you provide breadth 200, depth of 250, 4 to 4.8, 200 by 250. Now here reinforcement is telling stirrup, 8 diet 150 everywhere. Here it is 125, 125, 125. Now here is telling B1, B2, T1, T2. So that is telling us what is B1, what is B2. So B1 plus B2 is your bottom reinforcement, and T1 plus T2 is your top reinforcement. So here B1 means bottom reinforcement, 10 diato. T1 means your top reinforcement. Understood? So this is how it is given. Again, he is telling us what is T1 actually. So T1 means, again, this outer 2 bar will be your T1, and inside 2 bar will be T2. And here also, this outer 2 bar in the bottom will be your B1, and inner 2 bar is B2. Of course, in our drawing, since we are providing only 10 diameter 2 bar, this will be outer only. Inner bar it is not required. Here also T1, why they have T1? So again, 10 diameter 2 bar, it will be outer only. Suppose if they had given T2, then T2 in the sense it would have been your middle two bar. So we don't have such bars requirement here. Understood? So this is a typical for the lintel. Because lintel, they don't give you drawing like you give it for the beam. So they show you one typical drawing like this, and you go to the site. In the site, you do the measurement. What is the window opening you have? If your window opening is 3.5 meter, then 3 to 4 meter is this particular area. You provide a breadth of your lintel 200, depth is 250. Provide 16 diameter 2 bar at the top. Provide 12 diameter 2 bar in the bottom. Provide stirrup of 8 diameter at 125. Simple. Yeah. After that, I think beam is left out. I'll take up in the next lecture. Beam details is left out. Lab details is left out. And after that, of course, this is still pending. This particular thing is still pending. We'll take up it in the next lecture. And then I feel I should wind up the lecture. With that, most of the things we have understood. Why I'm telling all these things? Again, no, first of all, no one will tell you to this level. Second thing, as a structural engineer or as a site engineer, you should be knowing and you should know the um, theory and the concepts behind all these things. Simply reading the drawing, anyone can do. But if you understand the concept, why it has to be given and all those stuff, then you can enjoy on the site and you can guide anyone or you can speak technically with your seniors or anyone. We'll see you on the other side of the lecture. Thank you.